Languages. There are different types of language runtime types that have their pros and cons, as well as different types of programming paradigms that also come with their pros and cons. Choosing a language is not only just pros and cons of the runtime type and paradigm, but also the language features and the libraries that the community has. By the end of this section, you should be able to understand not only what kind of languages there are, but what are the common use cases for some of the most common languages used today. Runtime types. There are three major runtime types for programming languages. The first one is compiled to machine language, the second one is compiled to a virtual machine language, and then the last one is an interpreted language. We'll go over each one separately and explain what they actually are and what are the pros and cons of each language. Compiled to machine language. A program that is compiled to a machine language is a language that outputs something that can run by itself without the need of anything else other than the operating system. The benefits of a language that can compile to machine language are that it can be optimized to the hardware that they run on. So if you have hardware that is unique, with a compiled language you'll be able to target that hardware specifically. Another benefit of compiling to machine language is that it can be a lot faster. Because it's running directly on the operating system, it can run the commands per action to achieve something. If you're building something where every millisecond counts and you need to respond quickly, for example a safety feature within industrial equipment, then you would want something that can respond as quickly as possible. Another thing is that you can take advantage of the operating system features a lot better. So if you want to build a tool to help manage Windows desktops and use deep-rooted parts of the Windows API to achieve your goals, then a language that is designed for Windows that compiles to machine language is the best option. The downsides of compiling to machine language are that the executable is only built for one platform. So if you have something that is hardware independent and needs to run on any hardware or any operating system, then compiling to machine language is not a good option, as you would have to create many different versions for each hardware choice and each operating system you wish to support. Another downside is that the feedback loop is longer, as in it takes longer to test the change in development. If you want to be able to quickly make a change and see if it works while you develop, your development feedback loop is longer, as you first have to compile your application. This can take from minutes to hours. So often your developers would have to write code for quite some time before being able to see if that change works. The goal for a build time is around about 10 minutes. Examples are Go, C, Sharp and Rust. Compiled to a virtual machine language. A virtual machine is an application that acts as it is a machine. In this case, an application that takes a compiled application and runs like it is the machine and converts the virtual machine commands into machine commands. The benefits of compiling to a virtual machine language are that you have a single build that can run on any hardware or operating system supported by the virtual machine. That means you can build your application to run on multiple operating systems, such as Mac and Windows, with one version of your application. Another benefit is that the virtual machine handles a lot of the system level things for you. This would allow you and your team to just worry about your application needs and not worry about memory management, security and other things. So if you have something that doesn't need to deal with the small little details of the operating system, then a virtual machine language is a good choice. These languages are often very fast. A virtual machine language are compiled to an optimized version. During the compilation process, the compiler will automatically find optimizations in the run process to allow it to run as quickly as possible. So if you need something that is really fast, then a virtual machine language is a good choice. Application safety is another benefit from these languages. When these languages are being compiled, there are checks done by the compiler to ensure that the code is safe, and to run the code is searched for possible errors. This prevents the application from crashing in a way that would cause security flaws. One of the downsides of compiling to a virtual machine language is that the virtual machine runtime is often very bloated and requires a lot of resources to run compared to other runtime types. So if you're running your application on something that has limited resources, such as custom hardware devices, then a virtual machine language is not a good choice. Another downside is the development feedback loop is longer because it requires being compiled to a virtual machine language, and the compiler is checking for errors and optimizing the virtual machine commands. It can take some time to build. There are often tools to allow compiling of just certain files and merging it into the process, but this often still takes longer. Some of the examples of virtual machine languages are Java, Kotlin, and Scala. Interpreted languages. Interpreted languages are programming languages that are interpreted by a virtual machine at runtime. The virtual machine takes in the file that has programming language code and reads it and then executes it. The benefits of interpreted languages or the feedback loop for developers are a lot shorter. Because there is no compilation process, the change can be tested instantly after being written. This allows you and your developers to see if changes are working a lot quicker. Because the interpreted language runs on runtime, a virtual machine, your code will be able to run on anything that the virtual machine supports. This allows you to write code and run it on lots of different operating systems without having to worry about the internals of the operating system or the hardware it runs on. The downsides of interpreted language is it's not as quick as compiled language because the code has to be read and processed on each run, and the virtual machine has to boot up again. The performance of an interpreted language is not as good as compiled language. If you need to worry about the milliseconds and execution time, then an interpreted language is not a good choice. Paradigms. There are several programming paradigms where here we'll go over the most common object-oriented programming language, then others such as procedural and functional. While some languages are strictly one type of paradigm, many languages are hybrids and have functionality from two or more programming language paradigms. Object-oriented programming, OOP. One of the most popular programming paradigms is object-oriented programming. Object-oriented programming is where the code is built around the ideas of objects. This is a very good way of describing data entities. Two of the core concepts of object-oriented programming are classes and objects. A class is a template that the object is created from. Within a class, you'll be able to find the data points and functionality provided by the object. A quick example would be that which has its name, department, and role, and it provides functionality to introduce itself and tell people its name and department they work in and what they do within their department. Then we would have a programmer class that extends the employee class that automatically fills the department and role and only needs a name to be created, and it adds the functionality to fix a website. Then we have the customer support agent class that extends the employee class that again automatically fills the department and role and only needs a name to be created. This time it provides the functionality to answer questions. A programmer is an employee and a customer support agent is an employee, but a programmer is not a customer support agent. Both customer support agents and programmers can be used where an employee can be used, but neither can be used to fill each other's roles. Examples of object-oriented programming languages are Java, Kotlin, and PHP. Procedural. Procedural code is code that runs in a clear direction, one line after another. With procedural code, there are only methods, variables, and constants. A quick example would be where it connects to a MySQL database which returns a connection resource. The connection resource is then used to query the MySQL database to execute, which then returns a data result from the MySQL database. Each line runs after each other, one after another. Examples of procedural programming languages are PHP, C, and Python. Functional. Functional programming is designed to be more like mathematics, with values being immutable and things being functions. Functional programming languages are a good choice for applications where application safety is important. for applications where any error cannot be accepted. Due to the nature of not allowing values to be changed, these languages generally result in fewer errors. Examples of functional languages are Haskell, Kotlin, and Scala. The reality is, the paradigm of the programming language isn't that important, especially in a world where lots of languages are hybrid languages that mix two paradigms together. While the runtime types really make a difference and they have their pros and cons for various types of applications, the paradigm you use really matters. Object-oriented programming is the most popular and has the most best practices due to the amount it's used. Examples. Now that we understand what kind of runtimes there are, as well as the different kind of programming paradigms, we'll go over a few example languages and explain what runtime types they are and what paradigms they have, as well as giving some examples of what kind of applications they're good to build and what kind of applications you should not build with them. PHP. PHP is one of the most popular languages for building web applications. PHP was developed to build web applications and now powers a large percentage of the internet. PHP is an interpreted language. It's a good choice for building web applications. It's a bad choice for pretty much everything else, including long-running applications. Often when starting out, a company will use PHP for everything they do. This is a good idea. While it's not a good language for background tasks, it is still able to do these background tasks reasonably well. And at the start of your company, you do not need things to be perfect. You need things to work and to be able to move quickly. Having your background tasks in PHP allows you to reuse code from your web application, allowing you to move more quickly. And by the time you reach the bottlenecks in PHP's abilities for background tasks, you should have enough resources to be able to start rewriting these functionalities in different programming languages. PHP is a hybrid language that is a mixture between object-oriented and procedural, with object-oriented being the most popular form. Kotlin. Kotlin is a virtual machine compiled language that is built on the JVM, the Java Virtual Machine. It was built to fix perceived design flaws and pains with the Java library while allowing developers to continue to use Java libraries. Kotlin is a very good language to use to replace Java applications built on the JVM. The main usage would be to build Android apps, microservices, multi-platform desktop applications. It's not a good language to build embedded applications. Kotlin is a hybrid language that is a mixture between object-oriented and functional. Go. Go is a compiled language. It was developed by Google. It was designed to fix perceived issues with C and C++ and to make concurrency extremely easy. It allows developers to use C libraries. Go is very good at building embedded applications, microservices, APIs, system applications, applications that need concurrency, or applications that are required to be extremely performant. It is not a good choice for web applications. Go is an object-oriented language. Python. Python is an interpreted language. Python is very good for artificial intelligence and machine learning. It's a very good language to use for web applications and system scripts. It's not a good language for embedded applications or system applications. Python is an object-oriented language.